is still about a meeting between machine learning and spatial data from Kyoung-Sook Kim from the Advanced Institute of Technology in Japan. And now we will learn about GeoAI platform for personalized service.
Okay, thank you. My name is Kyoung-Sook Kim. Before I start my talk, I shortly introduce my institute. The AIST is the National Institute of Advanced Industrial Science and Technology. Still, I have some problem to remember of my full name of my organization. But anyway, so AIST is one of the national institutes in Japan, and then we actually have 7 research areas. It's not only the information technologies, also we have the in energy and environment area, or life science, biotechnology area, and also the material and chemistry and so on. And in my cases, I belong to the information technology and human factor. So inside of in this department, we also have the 3 research institutes, and then recently we have the 5 research centers. So what is a research center and research institute? So if you have curious, please come to me and at the break time. But anyway, I belong to the Artificial Intelligence Research Center, and he is my director of Junichi Zizi. And actually, have you heard of the super city in the concept? So recently in Japan, we have the new concept of the society 5.0, and it's new generation of the society after the information society. And after that, we want to combine the society 5.0 and then smart city, the concept. And so what is the difference of the smart city? And is the smart city individually have the certain physical systems, and now how can we harmonize of those different type of the physical systems? So it's all is connected each other, and not only connected, and they also have to coordinate it, is make the certain organization inside of the based on the heterogeneous smart city. And also finally we want to create a new value for the cities. But for realize of this concept, I think today's topic is very related. So IoT and robot and big data and HPC and AI is very important part to realize of these concepts. And what we are doing in ARC, so my research institute, we actually focus on the AI technologies embedded in real world. So, more closely, the AI want to closely related, equipped in real world. So we actually have several research team. So not only the IoT part, some research team is working on the sensing, how can capture the real world, and also some people working on the robotics. So how can act, give the real feedback to real world. And also HPC part, and then in my cases I'm working on the data platforms. And before that, I'm shortly introduce our supercomputer. This is one of the first level, top level of the supercomputer in Japan, especially to design of the AI. So what is the difference of the AI supercomputer and normal supercomputer? So number of GPU actually. So is 4,000 GPU is equipped of this machine. So nowadays is the ImageNet is very famous resource for the training data. So it takes just 2 minutes to train for the data. So that's why HPC is very important part to actually working on the AI. And that's why we actually build up this machine, and then last August we start of the operating. And this is very open infrastructure. So if you are interested in using this machine, then please feel free to contact us. And now, okay, so he's mentioned about the spatial data as well. So now I'm also working on the spatial data. And I actually want to be assured of the new vision. So what is the next generation of the geospatial data? So you know the map service is very popular in worldwide. And then also nowadays is location-based service based on the mobile devices. And after that, what kind of services we want to develop? So we think about the space-based service. So what is space-based services? Is actually, have you ever heard of the e-palette concept in Toyota? No? Okay, so recently Toyota is promote of their new concept of the e-palette. So what is the different thing is common, the location-based service. For example, is that is how to say, the Uber Eats, right? The Uber Eats. I want to eat the hamburger, then I put some people to deliver the hamburger. But the e-palette concept is they deliver the McDonald's. It's not only one hamburger. So what is the difference between the deliver the hamburger and deliver the McDonald's? It's because we have to decide on our decision before the order. But it's usually people want to actually before shopping or before eating, we want to see, and then after that we want to make the decision. So Toyota is they think if we realize autonomous driving, then they want to deliver, the shop itself or restaurant itself based on their autonomous vehicle. So there is new concept of the Toyota, and also we actually we have also similar concepts. Then how can we deliver? How can we organize of this kind of new, the spaces for each people? That's why my talk is how can we organize of the this geospatial information based on the different type of IoT data. But there's lots of issue. So what we are very limited resource. So we just working on a very small area. So what is the ARC GeoAI data platforms? Actually, we have two topics. So one is on-demand map generation for the high autonomous driving. So we want to actually create the map itself to support of the autonomous vehicle. Not only vehicles, it's a robot or a drone. Sorry. So several type of the autonomous, robots. How can we support of those autonomous, the driving? Because why we think about on-demand map? Because depend on their how to say the vehicle, the requirement of the 3D map, map for the vehicles and the robots and drones. Actually, they have different level, different requirement. For example, vehicles cases, they have the 20 centimeter error of the spatial data accuracies. But drone cases is we need 5 centimeter accuracy of the geospatial information. So depends on the type of the robot or type of the what they really work on the driving. So that's why we think about the new type of concept. How can we organize of the map itself on the map? And another issue actually mobility allocations for resource planning. So it's very related of the routing problems. But today I want to just mention about the first topic. So I want to skip this one. So is what is the difference of the map? It's a traditional map and then autonomous map. So this is show about the difference. And then for that, actually, sorry, I forgot this one. So to create of 3D map, actually is point cloud data. Have you heard of the point cloud data? So point cloud data is essential to create of the digital twins. It's actually the 3D map. So we actually look at the point cloud data. So this is actually new type of the geospatial data, but it's got quite big challenges. Basically, it's the set of the point, just x, y, z, but it's quite huge amount of the volume. So that's why we have faced of the challenge of the big data problems. So first of all, it's volume. More than 10 million points. It's just a few minutes. We are using the sensor, the LiDAR sensor. In just a few minutes, I have the 10 million points. And for example, this usually if I collected certain data, usually more than terabytes there. It's short area. And what is the problem is how can because of the volume, we have the problem to manipulation and visualizations. So how can we visualize? How can manipulate this kind of data? And also, it's variety problems. Various type of the sensor. There are different type of the sensor. Also, not only the sensor type, there are different type of the measure way. So it's we can use the satellite, our drone, MMS system, even the handheld system. So some people, collecting using the sensor by hand. People do that. So depend on the quality, it depends on the sensor or depend on the how to measure of the real world. So there are different accuracy, scale, and also density. There's also various problems. So that's why we actually have big problem of the alignment and registrations. Also, it's velocity. Now it's time. The radar sensor becomes popular. So it's every day they provide of the new type of new data. So how can we manage of this kind of update of this point cloud data? So this is one example. Is we have this is the image data, but compared to the images, point cloud data, they have lots of the noise or very not really difficult to recognize of this kind what is this one. And I will mention about the alignment and registration. So what is the alignment and registrations? Actually, this is the we collected of the 5 part of the data. So each color represented of the different area. But now I combine 4 space. Then what I should do that is I have to manually find out what is the matching point of each data. Then if I set up the each the matching point, then automatically we can create it of the whole space. But the problem is I have to manually do the select of that matching point. That means this is just one small area, but if we think about the urban space, but it is impossible to people working on that manual work for the alignment and registration. So how can we support? So this is basically our platforms to try to from the low point cloud data to how can we create it of the 3D model data. So for example, the point cloud data, the original data is 3 gigabyte, but if we create it of a 3D model, it's like the model data is like the cat, then it's less than just 600 megabytes. But currently, this work, actually human manually do this kind of work. So we want to support is more efficiently generating of the 3D model based on the point cloud data. And today, there are different. We have several technologies, but I want to shortly introduce the 3 technologies. First of all, the management of the point cloud data. So the one problem is how can we merge views of those local point cloud data into the global spaces. So we bring the concept of the discrete global grid systems. This is a new concept of the 2 reference coordinate reference systems. So geospatial data is actually coordinate the reference system is very, very important part. I think you guys already know about GeoHash. Have you heard GeoHash? Yeah, it's very, yeah, GeoHash is a very important part nowadays, especially to process of the big geospatial data. But GeoHash is actually some problems because each cell has different volume, area. So that's why we combine different type of the sensor data or data. Actually, it has certain problems. So nowadays, some people they propose new concept of the DDGS. This DDGS is the concept is they divide equal area of the the each area. So any cell they have the equal area or equal volumes. And this is very suitable for the manage of the point cloud data. So this is the example of the DDGS. So a little bit different, right? So it's this we use there are several actually ways to divide how to partition, but this is one example of the DDGS. But the problem is if we use this kind of system, for example, we want to support of the 1 millimeter of its accuracy of the point, then we need is more than 100 bit 100 bit data. That means it is not actually operated on the 64 bit machines. Why it has the more than bits? Because of the 3D. So we need X, Y, Z coordinations. And so we developed a new method to encoding or decoding of this DCS code. We created we used the bit operations to calculate of this code. So if you need more detail, and please contact me. And another issue is alignment and restorations. I already mentioned what is this issue. And this current system has actually the scalability problems. So many tools, they have this kind of functionalities, but still have they just only have the certain part of data. But we want to how can scale this algorithm. So we bring the Spark environment for the parallel processing. So there is actually several primitive operations to alignment and restoration. So first is plane detection part, and second is alternate closest point pairs, and then another is triangulations. So these three functions is very mandatory functions to handle the point cloud data for this issue. So we actually created we now developing of the 3 algorithms is with scale of the Apache Spark. So, for example, this is point cloud data of the Odaiba area. Odaiba area is my research center is located in, and this is the whole area over the Odaiba. And then what is actually plane detection is we it's kind of a clustering algorithm. We divide each plane of what is the main plane to representative of the point cloud data. So it's actually is clustering method of the point cloud data. And then, but the problem current algorithm have it's difficult to calculate this amount of the data. So we developed a new algorithm to handle this new handle of the detect of the plane information of the large scale of the point cloud data. And further is visualizing by the deep learning. Yes, almost. So it's one of the image deep learning is I think you guys already know, but recently it's point cloud data also they use some algorithm based on the deep learning network. One of these PointNet, a very early step of the algorithms. But it's basically not images. They use the 3D point and then to recognize what is the object or partially segment or semantic segmentations work. So we are using this algorithm, and then we are trying to enhance of the more good algorithm to recognize of this kind of issue. And of course, also when we build the new algorithm, actually we need training data. But the problem is, compared to the image data, so point cloud data is not much training data. So even though I want to create a new algorithm based on for my applications, but the most big work is actually annotations work to create of the training data. So we developed a new we developed a new tool to create of the how to efficiently create of the point cloud data to make the new training data for your applications. And finally, okay, and then also we working on some graph embedding technologies for the segmentation of the point cloud data, also augmented of the 3D solid model. So what is a graph embedding? Is we have the original graph, then we created of the certain features based on the embedding space. So if we using the graph embedding, so one is example of this one is they using the graph structure for the segmentation for the point cloud data, but we are working on this kind of issue based on the graph embedding technologies. So one is actually currently there are several algorithms is the work of node to that, but we actually developed a new method is to create to using the node similarities is in the object functions. So actually we published it on papers. And because of time, I'm sorry for to skip many parts. And recently, we set up OGC is one of those standardization organizations. And then recently, GeoAI, it's domain working group. I proposed this working group, and then we successfully set up this working group. So if you are interested of the activity of the OGC GeoAI group, so please contact us. Okay, thank you. Sorry for not much detail about the yeah.
You mentioned that this 3D model is meant for digital training, but digital training is very, very precise, accurate. But in the smart city like this, that could be a bit, there are some inaccuracy because it doesn't really have precise. So does that knowledge help you to do it strategy in a more efficient manner? Because some of your point cloud can be up to very, very accurate measures, but some of the application is from the smart city doesn't get so accurate.
Yeah, that's why we think about on-demand the creations. So basically, currently we cannot actually create the 3D map to satisfy all applications is satisfied. So based on our requirement of the application. For example, I want to using the autonomous creature. Then creature have the kind of certain accuracy. Then based on that accuracy, we try to generate it of the 3D map based on the low point cloud data. That is our concept of things. And then, but the problem is, actually the point cloud data is for robots. The point cloud data is very useful. A human is not map, right? So for the human, it's more vectorized map we need. It's like this kind of 3D model. But how can we generate it of this kind of 3D map informations from the raw data. That is a very big issue, and also we try to using the deep learning algorithm or certain traditional GIS algorithm to create those informations. So currently, 3D this kind of map, human working on the each by each. So it's very actually whole. This is Odaiba area, so please visit. So it's a whole area, and then even though we censor over this area to create the 3D map, it takes 2 months. So it's based on the point cloud data to create of the 3D model. Is that still we have lots of overhead. So how can we reduce those kind of costs to more support of the smart city application?
So the training part is still ongoing.
Yes, right.
So actually you mentioned 2 methods to model the cloud, the point cloud data. So the first one is to directly apply the point cloud data into the learning models. The second one is to transfer the point cloud data to the graph models and then learn the graphical features. So what's the difference between these 2 methods? And like the accuracy and the efficiency issues?
So it's totally different. PointNet is is same as the ImageNet. So they created the project of the XY projection or YZ projection and the XY projection. So they project the point cloud data and they created of the images, and then they try to create learning using the image deep model to recognize of the segmentations. But this one is they created of the graph based on the k-nearest. So based on the k-nearest, they created a graph, and then based on the graph, currently they just using the graph information.
You mean every point in the cloud is connected to the k-nearest point?
Yes. Yes.
It's a
So
point cloud graph.
yeah, point cloud graph. So this is point cloud graph, and then based on the graph, and then they try to using some graph embedding method to using the segmentate of the point object.
Okay. Thank you very much for a very successful presentation. Let us thank all the